let's be real for a second. If you build B4X applications, you already know that color selection can sometimes feel, well, a bit clunky, or maybe just visually uninspiring. Welcome to this explainer. Today, we're diving deep into the B4XDaisyColorWheel component to see exactly how it effortlessly elevates your user interface. It's a real game changer. Here is our roadmap for today. First, we'll meet the Daisy color wheel. Then we'll look at customizing it in the designer. After that, we're controlling colors with code. And finally, we'll wrap up with a real-world modal implementation. All right, let's jump right into part one. Meet the Daisy color wheel. The sheer visual flexibility of this component is wild. You aren't locked into one rigid, boring style. You can go with a standard medium-thin donut for hue selection, or, switch it up and opt for a large, thick donut. And what's really cool is that the outer ring isn't just a static rainbow. It actively reflects the color saturation directly within the hue ring itself. That gives your users immediate visual feedback as they adjust their selection, right there in the center square. Moving on to part two, customizing in the designer. Beautiful visuals are fantastic, right? But as developers, the real question is always, okay, but how hard is this going to be to configure? Well, when comparing these different configurations, you can see how tweaking just a couple of values completely transforms the whole footprint of the control. You can go from a delicate, thin wheel to a really bold, chunky selector just by changing the wheel thickness and handle size properties. The best part? You're saving yourself from writing a single line of tedious UI code. So the big takeaway here is that you have a completely comprehensive suite of no-code properties right at your fingertips. Looking under the hood at the component's source properties, we see exactly what's exposed to the B4X designer. You can set the initial color right out of the gate. You control the wheel thickness and handle size, which, by the way, both default to 24 dip. There's even a drop shadow property for the handles, and those sizes range from extra small all the way up to 2x large. And hey, if you want the control perfectly positioned, you literally just toggle center on parent. It is incredibly robust for rapid UI development. Okay, let's get into the engine room, part three, controlling colors with code. For us developers, it's all about intuitive control. The core API makes retrieving or assigning colors remarkably straightforward. Honestly, it acts as your ultimate Swiss Army knife for color management. Need the raw integer value? Just call getColor. Want to update the UI instantly? Call setColor. And the component automatically recalculates the values, redraws the hue disk, and updates the saturation value square for you. No heavy lifting required. Need web-friendly strings? GetHex and SetHex have you covered. And get this, SetHex is actually smart enough to clean up those pesky hashtag symbols and handle both 3-character and 6-character hex formats completely automatically. Continuing with the API, the sheer variety of supported color formats here is absolutely fantastic. Whether you're working with standard RGB integer arrays, independent HSV float arrays where the hue goes all the way up to 360, HSL arrays for lightness calculations, or those hex strings we were just talking about, the wheel supports the whole shebang. The component actually has dedicated math regions handling complex conversions, like RGB to HSV and HSL to RGB, completely behind the scenes. You just pass in your preferred data type and it seamlessly adapts. Now, any developer who has ever built a complex, scrollable UI knows the absolute pain of nested touch events. You know the drill. You try to drag a slider and the whole page scrolls instead. It's the worst. Well, the source code reveals a brilliant little detail inside the touch handlers, a method called disallowParentIntercept. Basically, when a user touches the hue ring or the center square, the component explicitly tells the parent view, like a scroll view, to stop intercepting touch events. This ensures that your drag actions inside the wheel are perfectly smooth and completely frustration-free. It's a small detail, sure, but it absolutely proves this component is truly production-ready. Which brings us to part four, real-world modal implementation. So let's actually put this in front of users, triggered as an interactive model pop-up. Notice how incredibly clean this looks. It sits perfectly centered over the parent view, providing a really distinct area for interaction with straightforward cancel and apply buttons right below. This is great because it keeps your main interface totally uncluttered while still offering a highly focused picking experience exactly when your user needs it. And when we look at the implementation, the logic flow is beautifully simple. Step 1, you open the modal on a button click. Step 2, when the user is done, you retrieve their chosen color with a single simple getter method, cwinModal.getColor. Step 3, inside the Apply Buttons click event, you instantly apply that integer to your interface elements, like, say, setting a button's background color, and maybe trigger a quick success toast message. Then just close the modal and you're done. It's clean, it's readable, and it's highly effective. With unmatched visual flexibility right from the designer, deep mathematical API control, and truly effortless real-world integration, this component completely removes the headache of color management. It leaves us with just one big question to ponder. When the UI heavy lifting is handled for you this elegantly, how much further can you push the creative boundaries of your next B4X project?